Cadmium is a toxic, non-essential heavy metal that's found naturally in Saskatchewan soils. It can accumulate in sunflowers, durum wheat, and even flax.
Cadmium is an emerging trade concern for the flax industry after a non-confirmed comment came from the Korean consumer market stating that our flax is high in cadmium. This effectively closed the Korean markets to our flax.
Agri-Food Canada and the University of Saskatchewan are breeding for low cadmium accumulating flax varieties. But in the meantime, this project endeavors to determine if management practices that have reduced cadmium accumulation in other crops will also work in flax. The project was developed by Ishita Patel from Southeast Research Farm. The study is evaluating the effectiveness of zinc and calcium fertilization to reduce cadmium uptake and accumulation in flax. The variety Prairie Thunder was used in this experiment as it's suspected of being more prone to cadmium accumulation. So let's go inside now and see how the zinc and gypsum treatments worked. Here's Ishita Patel with the results.
In August of 2021, the European Union set a maximum limit of 0.5 parts per million or 0.5 milligram per kilogram of cadmium for all imported flaxseed. This might present a significant trade concern for our producers going forward. We chose 4 sites in Saskatchewan for this experiment: Scott, Yorkton, Indian Head, and Redverse. We chose them because there was literature showing that they had good variation of naturally occurring cadmium in their soils. The experiment was set up as randomized complete block design with 4 replicates. For the zinc treatment, we used zinc sulfate pellets, and for the calcium treatment, we used gypsum or calcium sulfate, and this was a prill product. These products at the rates shown in the table were side-banded at seeding, and the results were compared against the control treatment of no zinc or gypsum. Through this project, we sought to establish cadmium levels in the soil and phosphortilizer used at each site. One of the ways cadmium is added to our soils is through monoammonium phosphate or MAP, or the phosphortilizer that we use to grow crops. Cadmium is present as an impurity in the rock deposits from which phosphate is mined, and its addition is one of the major sources of cadmium buildup in the soil. Next on our objectives list was to evaluate if any of the treatments led to adverse effects on growth and development of the plants. Third, we assessed how effective the treatments of zinc and gypsum were in reducing seed cadmium accumulation, and we compared the economic feasibility of these treatments. Before seeding, we took soil and phosphortilizer samples and sent them to the lab for cadmium analysis. At seeding time, the treatment of zinc and gypsum were side-banded, and the seeding rate used for flax was an average 45 pounds per acre at each site. After emergence, we did plant density counts and measured plant heights to see if any of the treatments led to seed mortality or stunting or affected the growth and development of plants in any way. After harvest, we measured yield and moisture and sent the harvested flaxseed samples to the laboratory for cadmium analysis. So here are the soil and fertilizer test results for each site. Soil cadmium level varied from being undetectable at Redverse to the highest being 0.5 parts per million at Yorkton. Cadmium in the phosphortilizer used by each site varied as well, and Yorkton was found to have the highest cadmium in its phosphortilizer and soil. Now, after doing some math, considering the amount of phosphortilizer used at each site, we figured that the cadmium inadvertently added to the soil through the phosphortilizer varied from about 1.4 grams per acre to 2.7 grams per acre. There were no adverse effects of any of the treatments on plant growth and development, as none of the treatments led to significant differences in plant emergence, plant height, or yield at any of the sites. Now, differences between sites were significant, where average plant density at Redverse was the highest, followed by Yorkton, Indian Head, and then Scott. This was probably due to slight differences in seeding rates at each site. In comparing yield, Indian Head and Yorkton produced highest flax yields, followed by Redverse and Scott. Now, let's look at the effect of treatments on cadmium levels in harvested flaxseed. In this plot, the same colored bars represent data from the same site. The sites are also listed on the x-axis with treatments going across from 1 through 7 shown in the table as well. On the y-axis is the average seed content of cadmium in parts per million in harvested flaxseed. This horizontal bar is where the seed cadmium level is 0.5 parts per million, which is the maximum limit set by the EU for all its imported flaxseed. Redvers was the only site where all of its treatments resulted in seed cadmium levels under the EU limit of 0.5 parts per million. For all other sites, most of the treatments resulted in flaxseed with cadmium level higher than 0.5 parts per million, even in the untreated controls, which are the highlighted bars. When comparing treatments within each site, most of the treatments did not significantly differ in seed cadmium content. The only significant difference was found at Yorkton, where treatment 4, which was zinc at twice the standard rate, significantly differed from treatments 2 and 7, which were zinc at standard rate and gypsum at twice the standard rate. Still, none of the treatments differed from the control, and so no treatment of either zinc or gypsum was effective in reducing seed cadmium content compared to the untreated control at any of the sites. Lastly, let's look at the economics of applying these treatments of zinc and gypsum. We calculated average yield revenue at each site by assuming the price of flax to be $18.50 per bushel, and the cost of zinc and gypsum products were given to us by their manufacturers. Based on these costs, we calculated how much each treatment would cost as a percentage of yield revenue at each site. For example, we calculated that the treatment of zinc at twice the standard rate costs 3% of the average yield revenue at Yorkton. And if you recall, this was the only treatment that was found to be significantly different at Yorkton. However, since none of the treatments at any of the sites led to a significant decrease in the cadmium level of harvested flaxseed relative to the untreated control, and because the cost of applying products is more than applying nothing at all, we did not find the treatments of zinc or gypsum to be economically beneficial in this project. In doing this project, we found that both soil and fertilizer are a source of cadmium, and when producers apply traditional fertilizer in the form of monoammonium phosphate, they inadvertently introduce cadmium into the food chain, which then builds up in the soil. This is particularly concerning since most sites had seed cadmium levels exceeding that level of 0.5 parts per million set by the EU. As a solution to this issue, perhaps producers could consider using phos from sources other than MAP. An option could be Strew White, which is purified from sewage wastewater, but cadmium testing is still encouraged, and we used AgWise Labs in North Dakota, so that's an option. Secondly, we found that zinc and calcium applications did not significantly reduce seed cadmium content compared to the untreated control at any of the sites, and as a result, these treatments were not found to be economically beneficial. We had high variability in the data in 2022, but we will be redoing this trial in 2023 and hope that the variability will be low enough to get some statistically significant results.